Hi guys, welcome back to chemistry. Hope your homeschooling's going well, not too boring. So what we're going to be looking at today is how to draw these molecules. I did a brief bit on it yesterday, but we'll do it more in depth today, and then you'll have a go to do it in your SciPad as well. So I'm just going to go over this diagram which we looked at yesterday, which is a bit of a cheat sheet to how many how many bonds each atom is going to form in a molecule. So we'll start with our most simple guy, hydrogen. So hydrogen here, he's just got one electron. He's just got one free unpaired electron, and that unpaired electron wants to share with another electron to get a full outer shell. Of course, hydrogen just needs 2 electrons in its first shell. So hydrogen is always going to form one bond with its one electron, and it's going to have no lone pairs. And we'll move to group 17. All of these ones have 7 electrons in its outer shell. So it's going to have 3 lone pairs of electrons and then 1 unbonded electron. That one unbonded electron will form one bond. Move to oxygen. It's going to form 2. It's going to have 6 electrons around the oxygen. 4 of them are going to be, there's going to be 2 lone pairs, so 2 pairs of electrons, and then 2 unpaired electrons, which will allow all of group 16 to form 2 bonds. Group 15 will form 3 bonds with 1 lone pair, and group 14 will form 4 bonds and have 0 lone pairs. So what we're going to look at today is how to draw these. So let's see if this works. Here's my sketch pad, probably big enough. So the first one I'm going to show you how to draw is this one here. Excuse my handwriting, I've done this before. That's H2O. 2 doesn't look like a 2. There we go. H2O or water. So hydrogen, we'll draw a Lewis diagram for hydrogen. It's just got 1 unpaired electron. Oxygen has an atomic number of 8. You can check the periodic table for that. So it's going to have 8 electrons. The first 2 go in the first shell, and then in the valence shell we're going to have 6 around it. 1, 2, 3, 4, 5, 6. 2 unbonded and 2 paired up. 1 hydrogen, an oxygen, and we're going to have another hydrogen here which has 1 unpaired electron. So what's going to happen is this: each hydrogen is going to form a covalent bond with 1 electron, 1 unpaired electron in the hydrogen. So these 2 are going to join together. Let me see how I do this. Erase it, nice. So those 2, oh, that's weird, are going to form a bond. And these 2 are going to form a bond as well. Just give me a moment how to work this out. I do colour. Not really what I wanted to do, but whatever, works. So there's going to be a bond here. So what we have is we have the oxygen, 1 bond to the hydrogen, 1 bond to that hydrogen, and then 2 lone pairs. So this hydrogen has 2 electrons in the bond. This hydrogen's got 2, so it's got a full shell. And this oxygen's got 1, 2, 3, 4, 5, 6, 7, 8. Let's do a new one. New. Blank. All right. Next one, nice and even simpler, is going to be HCl. we said before, hydrogen has 1 electron there, and chlorine has an atomic number of 17. So it's got 2 in its first shell, 8 in its second shell, and then 7 in the valence shell. As so, and 1 there. Chlorine needs 1 to get a full shell, hydrogen needs 1 to get a full shell. So they're going to share these 2 electrons and they form a bond, like that. So HCl is going to look like 1, 2, 3, 4, 5, 6, 7, 8 around the chlorine and 2 around the hydrogen. Let's do another one. No. New. Alright, the next one is CH4. CH4. Carbon's got an atomic number of 6, so it's got 2 electrons in its first shell, then 1, 2, 3, 4 in its outermost shell or valence shell. And because there's only 4, they are going to be all unpaired. Remember, when we start putting them on, we start at the top, right, bottom, left. There are going to be 4 hydrogens around it. And each hydrogen is going to have 1 electron. And these 2 electrons are going to form a bond. So if 1 bond here, 1 bond here, 1 bond here, and 1 bond here. So each hydrogen has 2 electrons from each bond, and the carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Final one. Last one we're going to do is NH3. It's all seem to have hydrogen in them for some reason. So nitrogen, it has an atomic number of 7. So it's got 2 in its first shell, and then we do 5 in the outer shell. Start at the top, and then start doubling up until we've got 5. We're going to have 3 hydrogens around it, and you've probably worked out they're going to pair up with the unpaired electron and form a bond. Once again, each hydrogen has 2 electrons and the nitrogen has 8 electrons around it. In the book, in the SciPad book, it has a different way for you to do it. You can read the method, you can go through it and follow it. I find it a lot more difficult than it's needed to be, but it does work. So for example here, what it asks you to do is, and I want you to do it this way when you do it in the book. Afterwards you can do it whichever way you find easier. H2O, total valence electrons. Hydrogen has 1 valence electron each, so that's 2, and oxygen's going to have 6, so we have a total of 8 valence electrons. And the amount we need for a full shell, oxygen needs 8, and each hydrogen needs 2, so 8 plus 2 plus 2 is 12. And then you subtract the big number minus the electron shared is going to be the big number minus the small number, 12 minus 8, which will give you 4. And then divide that by 2 and it'll give you the amount of bonds you need. Then you can work out your answer. I think it's pretty obvious that there's going to be 2 bonds anyway, but if you want to do it that way, you can. I shouldn't give you those answers. Stop doing that. All right. So I want you to complete 45 and 46. And then you are going to be doing page 47. Now for page 47, it is a little different. This loads. Give me a little while. All right, so some molecules. Crikey, is that working? One second. There we go, we're back on. All right, some molecules. Yes. Just give me a second. All right. Man, sorry about that. Got a dodgy computer screen. All right, so sometimes these molecules are going to need things called double bonds. So a single bond is where two atoms share two electrons, one from each. In a double bond, each atom is going to share two electrons. So here is oxygen. We know that oxygen has 6 in its outer shell, but it's got 6 in its outer shell, so each is going to need 2 more electrons. If it makes a single bond, each oxygen will get 1 electron, but if it makes a double bond, it will get 2 electrons from the other oxygen. So if we remember each of these bonds is worth 2, this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. And this one's going to have the same. So in a double bond, each atom contributes 2 electrons, 1, 2, 1, 2. There are a total of 4 electrons in a double bond. So each oxygen has 8 electrons in its valence shells, 4 from lone pairs, 1, 2, 3, 4, and 4 from the double covalent bond. Let's have a look at this again. So I'll do an example of one that's got double bonds. It'll be quite a difficult one. So this thing here, CH2O, we're going to try to draw that molecule. So carbon, 1, 2, 3, 4. Oxygen, 1, 2, 3, 4, 5, 6. And 2 hydrogens. Down from 2 hydrogens, all right. So hydrogen, they're going to make 1 bond each. Carbon is going to make 4 bonds, and oxygen is going to make 2 bonds. Now the way I would do this is I will put the one which makes the most bonds in the middle, which is going to be carbon. We know the hydrogens are going to make 1 bond each, so each one of these electrons is going to be bonded to 1 hydrogen. Now this carbon's got 2 more lone electrons for bonding, but there's only 1 more atom, the oxygen, for it to bond with. However, he's got 2 unpaired electrons, and so does oxygen, so it is going to form a double bond. That one with that one, and that one with that one. Make sure you draw in these lone pairs at the end. They still exist. I may have forgot to have done that in some of my last ones, so make sure I did. And this is our complete Lewis diagram for CH2O. Stop that, go away. All right, so I'd like you to complete page 44, 45, and 46. Make sure you use the periodic table, and then page 47. Page 47 and on page 47, it is got double or triple bonds in it. triple bond is with 3 electrons being shared. This last one down the bottom, HCN, it's a nice tricky one. The atom with the most unpaired electrons is going to go in the middle. That's my hint for that one. Alright, so we're going to leave it at that today. Complete the pages 47, 46, 45, 44, and I will assign you some work on Education Perfect. Tomorrow I'm going to try to organise a Google Meet for us at some point, probably around 1 o'clock actually. I'll send you an invite for that, and it'd be really cool if you could come along to it and we can talk about how everyone's going and you can ask me any questions. But I'll send the invite for that soon. Alright guys, that's all for me today. See you later and good luck.